Hey everyone, and welcome. We all love SQL for asking questions about our data. It's amazing at that. But what if we could teach the database to do more? What if it could not just answer our questions, but enforce rules, run calculations, and automate tasks all by itself? Well, today, we're going to dive into how we can embed logic directly into the database, turning it from a passive storage box into an active, intelligent partner in our applications. So, if you're a developer, you've totally felt this, right? You're in the zone, writing your Python or your Java code, and then you have to stop and write an SQL query. The whole mindset just shifts. It can feel like you're trying to fit a square peg into a round hole. It just feels awkward. So, what is going on here? What's the fundamental disconnect? The heart of the problem is what we call a paradigm mismatch. SQL thinks in big, broad strokes. It thinks in sets. You tell it, hey, get me all the customers from Texas, and boom, it gives you the whole group. But our application languages, they usually prefer to work one-on-one. They like to loop through data one row at a time, processing each customer individually. They're basically speaking two different dialects about how to handle data. Now, the classic way to solve this, to bridge that gap, is with something called a cursor. What a cursor does is it takes that big set of results from your SQL query and kind of turns it into a single file line that your application can walk through, one row at a time. It's like a translator between the two worlds. But this can create a ton of network chatter, a lot of back and forth between your app and the database. And that leads us to a really, really powerful question. Instead of pulling all this data out of the database to process it, what if we could push the logic in? What if the database itself could handle these complex tasks right there where the data lives? Well, the answer is a huge yes, and that's exactly what SQL/PSM, persistent stored modules, is all about. All right, let's start with a really common challenge. How do you handle a calculation that you need to use over and over again, like, say, taking a first name and a last name and formatting it into a last name, first name string? You definitely don't want to rewrite that logic in every single query. The solution? A user-defined function, or, as we call them, a UDF. To put it simply, a UDF is like your own custom formula that you save inside the database. You can give it some inputs, we call them parameters, have it do some work, like that name formatting or maybe calculating a final price with tax, and it hands you back a single, neat result that you can use right in your SQL statement. Now, UDFs come in two main flavors. First, you have your scalar function. This is the most common kind. It takes in some info and returns one single value. You give it a first and last name, it gives you back one formatted string. Simple. But then you have the more powerful table-valued function. As the name suggests, this one returns an entire table of results. You could use it to generate a really complex report, and then you can query that report just like it was a regular table. Pretty cool, huh? Okay, so functions are fantastic when you need to call them on purpose. But what if you need the database to do something on its own? To react automatically when something happens, kind of like a motion sensor that turns on a light. For that kind of job, we need triggers. A trigger is the special little program that you store in the database, and it automatically gets fired or executed whenever someone tries to change data with an insert, update, or delete statement. The key thing here is you don't call a trigger. It just runs. This makes it absolutely perfect for things like keeping an audit trail of changes or enforcing a really complex business rule that a simple check constraint just can't handle. And what's so fascinating is this invisible process that's happening behind the scenes. Your application just sends a normal update command. But before that change even hits the table, a before update trigger can fire automatically. It can inspect the new data and check it against a business rule, like, say, an employee's salary cannot be increased by more than 10% in one go. If that rule is broken, the trigger can just stop the update dead in its tracks. The database is literally protecting its own integrity. Okay, so we can reuse calculations with functions, and we can automate reactions with triggers. But what about when you need to bundle an entire sequence of actions together? A whole business process, like setting up a new customer. That might involve creating a record in the users table, then another in the billing table, and maybe one more in the sales log. It's a multi-step operation. This is the perfect job for a stored procedure. Honestly, just think of it as a complete program or a script that you save right inside the database. It's a pre-compiled block of SQL. It can have if-then logic, error handling, the whole shebang, all ready to be executed as one single atomic command. And doing things this way has some huge advantages. Instead of your application sending 5, 6, 7 different SQL commands over the network, it just makes one single call to the procedure. That massively reduces network traffic. It also centralizes your business logic. If a rule about new customers changes, you only have to update it in one place, the procedure. And from a security perspective, it's great. You can give an app permission to run the procedure without ever giving it direct access to the tables underneath.
Okay, we've got functions, we've got triggers, and we've got stored procedures. They're all awesome. But now for the million-dollar question. How do you decide which one to use and when? Let's break it down.
This is where it all becomes crystal clear. Let's start with how they're invoked, or how you run them. Functions, you use them right inside a SQL query, like in a select statement. Procedures, on the other hand, you have to call them out specifically with a command like execute. And triggers, well, they're the special ones. They're invoked automatically by a data change. You don't call them at all. From there, their return values and their primary uses are just as different.
So here's the simple cheat sheet. The real takeaway is this. If you need a reusable calculation inside a query, use a function. If you need the database to automatically react when data gets modified, use a trigger. And if you need to wrap up a whole multi-step business process into one single callable package, use a stored procedure. It really is that straightforward. It's just about picking the right tool for the job.
So at the end of the day, what's the big win here? What do we gain by doing all this? Well, we make the database a much smarter, more active partner in our whole application architecture. By moving logic into the DBMS, we centralize our business rules, we can seriously improve performance by cutting down on all that network back and forth, and we can build a much more secure system overall.
But all this power comes with a question that's worth thinking about. By putting so much logic inside the database itself, are we building this beautifully robust centralized system? Or are we accidentally creating a kind of black box that might make it harder for application developers to see the whole picture, maybe creating a hidden dependency they don't know about? It's a really critical architectural trade-off to consider in your own projects. And that's our look at embedding logic directly into your database. If this helped you think about these tools in a new way, I'd really appreciate it if you'd hit that like button, share this with a friend, and subscribe for more deep dives. Thanks so much for watching.